Hey, so I'm going to work the surface area and volume question from the math lab, but before I do, I just want to do a really brief example of what exactly the difference between surface area and volume actually is, because sometimes I think that makes that helpful when you're trying to figure out how to use the formula. So what I have here is an actual online model of the exact same box that we just did. The width is still the same 15 units from the example problem. The length is 10 and the height is 5 units. You can tell by looking at the little grid marks on the drawing. And I'm going to do volume first because that has a tendency to be the one that's a little bit easier. So I'm going to tap on the box and kind of open it up here. When you are finding the volume of a shape, you're actually trying to figure out how much space is on the inside. So in other words, if I were going to take this box and fill it up with cubes, and I'm going to do that by hitting this little cube button here on the online. So see, I'm filling it up with cubes right now. If I were going to fill up the box with cubes, how many cubes would it take to fill up the box? And that is actually why we use cubic units when we're finding the volume of something. So the example problem we're getting ready to go back to in a second was in centimeters. So once we find the volume of this box, it's centimeters cubed, and that's for a very specific reason that we use cubed, because it's literally saying if we were going to fill up this box with cubes, how many would fit in there? So you'll notice that the first row that I just put in the bottom of the box, it took 15 cubes, and that's because the width of the bottom of the box is 15. So if I wanted to add more rows of cubes to fill up the box entirely, I would figure out how many rows to put in there by looking at how long the box is. And we know that the box has a length of 10. So that means it's going to take 10 rows of cubes to fill up the box. So I'm going to go ahead and do that now. So there's already one row. So I'm going to put in 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I filled up the bottom of the box, and I knew that because it was 15 wide and because it was 10 units long, that if I did 15 times 10, it's 150 cubes that are in the bottom of the box. Now, of course, that just fills up the bottom layer. We have to actually fill up the entire box. So how many layers do we actually need to put in there? And, of course, we use the height to figure that out. So the height of the box, we know that the box is 5 units high. So I need to put 5 layers total in there. So I put 1 layer already. So 2, 3, 4, and 5 layers of cubes. Now fills up the box all the way. So how many cubes did it take to actually fill up the box? Well, first I had to do the length times the width. Okay, and of course the length was, again, 10. The width was 15. So we did 15 times 10 to figure out how many cubes went in that bottom layer. And then we multiplied by the height of 5 to figure out how many layers to put in there. So that is where the formula for volume comes from. That formula, length times width times height, we actually did 10 times 15 times 5, and that is why the volume of the box is 750 centimeters cubed. And again, we use cubic centimeters because it's literally how many cubes fit in the box. Okay, now let's take a look at surface area. So I'm going to get rid of all these cubes. So the volume was the amount of space inside of the box. The surface area is literally the space, the area on the outside surface of the box. So basically, if we were going to unfold the box, how much space, how much area is out on the surface of the box? And the formula for surface area can be a little bit confusing, okay? I completely understand that. The formula that is given to you in my math lab which is given to you right here. This is what the My Math Lab gives you. It can be a little bit confusing, but all it's really asking you to do is find the area of each of the sides of the box. Okay, so let me show you what I mean. So the 2 times length times width. Is saying, take the length and the width. Okay, we know that, again, we know that the length is 10 centimeters. We know the width is 15 centimeters. So length times width, so 15 times 10, and multiply it by 2. That's the first part of the formula. So what it's really asking you to do, I'm going to unfold the box here now. We're unfolding it. So what it's asking you to do is just find the area of each face of the box. Okay, so I'm going to start with the front and the back. So the front of the box, this purple side, we know is, actually no, I'm not going to start with the purple side either. I'm going to start with the bottom. So the width of the box is 15. The length of the box is 10. So I'm basically finding the area of the bottom of the box when I do 2 times width times length. It's asking me to find the area of the bottom of the box, which is why we do 15 times 10. And then, of course, if the area of the bottom is 15 times 10, the area of the top of the box is going to be exactly the same. So that's why you multiply it by 2. So the bottom of the box is, again, 15 times 10. And then we're going to take that 15 times 10 and multiply it by 2, because that tells us the top and the bottom. Okay, by the same token, the sides, I'm going to pull up this red side right here. Okay, so the red side of the box, the length of the box is 10. The height of the box is 5. So if we do 10 times 5, that will give us the area of the right-hand side of the box, which means that the left-hand side of the box is going to be the same. So that is why another part of the formula is 2, times the length times the height, because you're just finding the area of that side of the box and then you're multiplying it by 2, because if the right hand side of the box is the length times height, then the other side of the box has to be the same. So now let's translate that. So now back to the My Math Lab problem where it's asking you to find the surface area of the box. So I'm going to first of all label, this is my width, this is my length, this is my height, although it really doesn't matter which one you label as length, width, and height. And now I'm going to rewrite the formula up here at the top. So surface area, I'm going to look at the first part first. So 2, sorry about that. Let me get my drawing back there. Sorry about that, guys. Okay, so surface area, the first part of the formula, so the 2 times length times width. So that part right there. So I am going to look at my length, which is right here, and multiply it by my width. So what it's really asking you to do, remember when we unfolded the box, it's asking you to find the area of the bottom of the box. And you find the area of the bottom of the box by doing the length times the width, which of course is 10 times 15. If the area of the bottom of the box is 10 times 15, that means the area of the top of the box is the same. So that is why the formula is telling you to do 2 times length times width. So 2 times 10 times 15. The next part of the formula says plus 2 times width times height. So the width times the height, if you multiply those together, that's going to give you the area of the front of the box right here. So the width is 15 times 5. And if the front of the box is 15 times 5, then the area of the back of the box is going to be the same. So that is why the formula is telling you to do 2 times width times height. And then finally, the last part of the formula is 2 times length times height. So the length is 10, the height is 5. So if the height over there is 5, that means that the height over here is 5 also. So what it's really asking you to do is find the area of the side of the box by doing 5 times 10. Well, if the area of the side of one side of the box is 5 times 10, the area of the other side of the box is 5 times 10 also. So that is where you're multiplying by 2 as well. So now that we have substituted all those values in here, so 2 times 10 times 5 gives you 300, plus 2 times 5 times 15 gives you 150, plus 2 times 5 times 10 gives you 100. So if we add 300 plus 150 plus 100 together, we get a total of 550 centimeters. And because we're doing surface area, it is centimeters squared.